Hello students, welcome to the pre-lab video for simple harmonic motion. We might also call it simple periodic motion, and it's a little bit like uniform circular motion. And we see this type of motion in at least two cases here that I'll demonstrate today, that of the simple pendulum and the mass spring system. So here we have a spring, and it has been elongated with a mass, and in this case just a mass carriage itself by itself. And if I disturb it, if I elongate it a little bit and release it, we see it oscillates back and forth in a regular periodic way. We see the same thing with the simple pendulum. I just have a string with a mass hanging here, and if I disturb it from the equilibrium position and release it, it too oscillates back and forth in a regular periodic way. It's very important to study this type of motion. Now, we may not be considering the mass spring system or the pendulum system in our work, but it turns out this type of motion turns up in many different areas in nature. So if we know a little bit about how to analyze the pendulum and the mass spring system, we can translate that knowledge into other areas, and it turns out to be a very useful idea for understanding motion in other areas of nature. So I'll demonstrate how to work with these two setups today and the important things you need to know to use these to get effective results. So the mass spring setup here is just a little stand, and notice there's a little scale on the front in centimeters there. You have a spring. It is already elongated by a little mass hanger here. Notice on the little mass hanger there's a little pointy thing that comes out of the bottom there, and that's just an aid for the eye, so you can kind of see where the bottom of the mass holder is with the scale here, the measurement scale here, because that is useful. So for the mass spring system, we're going to find out, how mass affects the period of the oscillation, and also how the amplitude affects the period of the oscillation. Well, what is the period? It's the time for it to go through one complete cycle. One of the first things you'll probably have to do with the mass spring system is determine the spring constant for the spring. So to do that, you'll have to, with no mass on the carriage, record the position there, and then place just a little bit of mass, no more than a gram. It doesn't take much to elongate this spring. It will go down to a lower position. You'll record that position and the total mass on the carrier, and maybe even do it one more time. And with those data points, you can establish the spring constant, because, of course, the elongation is directly proportional to the force for Hooke's law spring. So that will be probably the first thing you will do for the mass spring system. Then you will simply set it in motion. You'll have a particular mass on it, and you'll record the amplitude. Well, what do we mean by that? Knowing the equilibrium position where it is right now, I'll pull it down, say 1 centimeter on the scale. That will be my initial amplitude, and then I will release it with a stopwatch. I will time how long it takes to go through, say 10 complete cycles, and then divide it by 10, and I have the period then for that particular starting amplitude and the mass on the hanger. So I would want to repeat this experiment. I'll now consider different amplitudes for the same mass, so I would maybe bring it down to 2 or 3 centimeters, release it, measure the period again. So notice it can get chaotic if you're not careful about the way you release it there. And I would do it for several different amplitudes at the same mass. Then, to see if mass affects the period, I will use the same amplitude, and I will do it for several different masses. So you'll have a table of data, different periods, same mass, different amplitudes, same amplitude, different masses, and you'll be able to state, hey, mass does or does not affect the period, amplitude does or does not affect the period for the mass spring system. So then we'll move on to the simple pendulum. It's a simple thing here, obviously, just a little arm and a string that goes down to a little hanging mass like that. Amplitude here would be, the distance from, or the angle from the perfectly vertical position, and of course we can measure the mass of this by putting it on a pan scale. And then also the length for the pendulum would be the distance from here to the center of the mass. in this case, we want to determine, does mass affect the period for the pendulum, and how does the length of the pendulum affect the period for the pendulum? So it's kind of neat in this case to record the period. We'll use the Pasco photo gate timer, and let me show you how that works. It's a little box you've seen before with the timing mechanism in it, and then you have a little photo gate here. And when the pendulum breaks the light beam between the photo gate, it will start the timer. When it comes through the third time, it will stop the timer, and that will give you the time for one period very accurately. So I'll just demonstrate how that works. I'll move it out here, making sure that it's in the path of the pendulum, and you have to turn it on and put it in pendulum mode, and then hit the reset button, and it should read 0. Now it should be that when the pendulum first breaks the light gate, it starts the timer, and it will stop the third time through and record the period. And you see it did. It's there on the device for me, and it looks like it's 1.151 seconds, the period for that pendulum there. Let's just do it one more time. I'll reset it. It goes back to 0. And again, I can record the period for that pendulum, again, about 1.15 seconds. So as I said, you want to see what effect mass has on the period of the simple pendulum. So keeping the length the same, I would use a different hanging mass, and I would repeat the same experiment. Now, I want to see if length affects the period for the simple pendulum. So leaving the mass the same, I want to change this length here. And let me give you a little hint. Rather than having many different strings of different lengths, just take one long string, and you'll notice here I have it wrapped around the little hanger here many times so that it's firm, and then I just bring it around here and keep it out of the way. And that way I can easily change the length without having to change my setup completely. So let me just demonstrate that. I'm going to move this up so we can measure the period for a different length here, but the same mass. And so I'm going to just lower this down here like this, and then I will firm it up here by going around many times over the hook like this. You can go as many as you would like. Probably the more the merrier. I'll bring it around here just to hold it in place, keep it out of the way. And making sure, oops, kind of got away from me there. Try it again. But you get the idea. This is how you would increase the length of the pendulum. It's still much easier than having a different string for every particular length. So making sure everything is good and tight here. So then I have a different length now. And I'm just going to hit reset here, and let's just find out what the period is. We've changed the length. So there we have it. We have 1.39 in this case, so that's interesting. So that's how we would change the length and see what effect that has on period, keeping the mass constant in that case with the simple pendulum. So two very simple setups that demonstrate simple harmonic motion, and we're going to measure the period in both cases and discover what factors affect the period in both cases. So very simple lab. You should have no trouble pulling this off. So I'll look forward to seeing you in the lab.